by for tutoring, and I'll tell you. Okay, mathematics of finance. So we're going to start today looking at equations that calculate interest, or that use interest in some sort of a way, sometimes to your benefit, sometimes to your detriment. Your benefit, things like if you invest money in something called an annuity, which we'll talk about, or if you invest money, or you just simply put money in a bank account that earns interest, then you're going to slowly over time make money on that. Or there are some situations where it's to your detriment, where if you like take out a mortgage on a house or something, they're going to charge you interest on that or whatever. Or if you have a late payment on a credit card, they're going to charge you interest on that. So in those cases, the interest is working against you. Okay, so the first equation we'll look at with this stuff, though, is the interest compounded annually. And it simply does this. It is A equals P times 1 plus R to the N. And what all of these variables are in here, A is simply the amount of money that you will end up with when you're done. P stands for principal. Anybody know what the principal is? Exactly. It's kind of the fancy finance word for, it's the initial amount of money that you put into an account or an investment or whatever. Okay. R is the rate. So you always hear about all these interest rates. You know, oh, we have 2% APR and blah blah blah. That's the R. Okay. And then the N is the number of years. Now this equation should look somewhat familiar. Anybody remember seeing something that looked like this before that we've looked at? What was it? Yeah? It's exponential growth. Okay, we talked about population growth, right? This should be the exact, almost, equation, just the letters have been switched to different letters this time. But other than that, the setup of it, the structure of it is exactly the same as a population growth. So when you guys were doing those questions about, you know, the Smallville is growing by 3% each year, what's the population after 10 years if the population is 100,000 this year, blah, blah, blah. Same type of a thing for this one, okay? So basically what this is doing is it's giving you some rate, okay, the R, of growth of, like, let's say you have some sort of bank account where you just put your money in there and let it sit and don't touch it. Okay? You don't put any more in, you don't take any more out, you just put it in there and let it sit. And it earns a certain amount of percent interest every year. So at the end of every year, they're going to give you a nice little bonus and stick it in there for you, and then that's going to so then that new amount's going to sit in there for another year, and at the end of that second year, then they're going to say, hooray, here's some more money for having your money in our bank, and then it keeps going. Okay? Yeah, usually it's like the interest rate for most savings accounts right now is like 0.5% or something. It's really, really tiny. It's kind of what? Well, depending on where you're at, because where I'm at, our bank, if you have like a minimum amount, then they give you a nice rate. So 0.5 for a savings account, yeah, is actually pretty good. But in any event, so let's say John puts $200 in a bank account that earns, and we'll say the 0.5% annually. So how much will the account be worth in 30 years? Okay, so we're going to look to see is investing in just a regular bank account over a long period of time a smart idea? I got $200. I'm not gonna touch it for 30 years. I'm gonna put it in this bank account and I'm gonna make all kinds of money. Let's see what happens. So, and it's even at a 0.5%, which is supposed to be a really good one. So, all right. So A, the new amount is gonna be the principal, $200, right? That's how much he's putting in there. The rate is 0.5%. So as a decimal, 0.005, right? 50% would be 0.5, 5% would be 0.05, so 0.5% is 0.005. And then the number of years I'm holding it in there, 30 years. So how much money do I have? Figure it out. What's 32?
No, that's how much you make. It's $32.
Oh, so I have $232.28, you said? So after 30 years of waiting on this money, my nest egg to finally come back to me, I've made $32. And that's on a good account. Okay? Yeah?
I did quick math on my savings account.
Yeah.
In between the two areas, and I'm earning like 40 cents a year.
Dude, that's awesome.
Yeah, it actually is how much is in there. It's pretty sad.
So if you have a bank account that compounds annually, yeah, maybe not such a great idea to just put all your money in there. There are accounts that compound at different intervals, not necessarily every year, but maybe every month it recalculates and gives you some extra cash or whatever. So these are called the compound interest situations. So in compound interest, it looks like this. Okay. And it's kind of the same stuff as far as the A, the P, and the R. A is the new amount of money you're going to end up with after a certain amount of time. P is the principal. R is the rate. And K, this new variable in this one, that is the number of compounds per year. Okay, so let's do just a couple quick calculations here. So if I have a bank account that compounds my interest for me every month, what's my K? 12. What if it compounds it daily? 365. Yeah, 365.25 for leap years. What if it compounds quarterly? 4. If it compounds semi-annually? 2. Okay, so it's however many times in the course of a year it's going to recalculate it for you. Yeah.
What's the percent that banks give you if you have a lot of money?
What's the what?
Percent like banks will give you if you have quite a bit of money. It's like I heard if you had put $1 million in the bank, you can live off it the rest of your life.
Yeah. But you know what? If you have $1 million, and that statement though, where they say if you have $1 million, you can live off the interest. Usually, it's not just like putting it in a regular bank account. They're probably talking about investing it in something and living off of that interest, which we'll talk about in a little bit. Probably an annuity of some sort. And then there's also T, okay, and the T is the amount of time in years. Okay, so I'm going to use this one. We're not going to do quite the same thing though, because we solved for A in the last one, and that was super easy. You just plug the numbers in and go. So let's solve for something different, okay? So we can get a little practice doing that. So let's say Joe puts $1,000 into an account that compounds, let's say it's a weird one, Usually it's monthly, but let's say every week. So he's like, woo, it's every week. Gets a little extra. So compounds every week. How long until he has doubled his money and let's say this, like, he just got a crazy good deal. Let's say it's a 2%, like, really good one. Okay. So they said, hey, if you're going to put that $1,000 in here, we'll give you 2%, which is really unrealistic, but just for the sake of crunching numbers that are easier, let's say that. All right, so we're going to work backwards on this one here. So the A, whoops, we already know the A, right? What's the new amount we're going for here? $2,000. Okay, so 2,000. Principal was the rate was 2%, so 0.02. And what's the K? If it's weekly, 52. And then raised to the 52t. And we want to solve this for t. Okay, so step me through it here. What should I do first? All right, divide each side by 1,000. That's going to give me 2. And then could crunch the numbers here in the parentheses, right? Put that all together. So 0.02 divided by 52, and then add that to 1. And with these kind of equations, you're going to get some decimals that are super duper tiny, and it's important to take a lot of decimal places, because if you start to chop these off, you're going to be way off. So I'm going to go 1.000385. I'm going to hold on to 6 of them. Okay? Because what would happen if I rounded that to 1? You'd go nowhere, right? It'd be like the interest rate was 0%, and that's not the case. I want to be making some money here. So what's going to happen with these is you're going to have bases that are very, very close to 1, just a little bit bigger, and you're going to have exponents that are huge, like 52 times t, right? I mean, that's going to be a big number when we're done. So we want to hold on to these decimal places so we don't lose that. This stage, though, what should I do to solve for t? Got to turn it into a log, right? And the log, this is the base, right? This big 1 point whatever. So log base 1.000385 of 2 equals 52t. All right, so you can do your change of base, right, to calculate that log if you need to, if your calculator won't do it for you. So log of 2 divided by log of 1.000385. So I got something about like that, 1,800. All right, so take that, divide it by 52. Oh, yeah. It's only going to take my brother's name is Joe, that's why I use that one. It's only going to take my brother about 34, 35 years to double his money. Even at a 2%, which is like impossible to find. Depends on what? Well, if it's a bank account where 2% is unheard of, but yeah, there are certain other things where they'll give you a 2% if you have enough money and it's a different kind of account. But anywho, does the math make sense though? How we did that? Plugging it in and solving. Okay, just got to pick the correct equation. Now, some people have when do I use the annual? When do I use the compound? What about setup tells you this was a compound interest problem? Look at the vocabulary in the. It says compound, right? Or you might see it say like recalculates every month or day or whatever. So, be on the lookout for those like little, clues in the problem. that'll tell you that you need to use that one. Okay. So one which doesn't really get used very often, but does exist for certain situations, and this is called continuously. Holy, super awesome deal. What this one does is it recalculates the interest, and it keeps adding on the interest all the time, like instantaneously. It doesn't stop. It's always adding interest. It's like you've taken your k and let k go to infinity. So it's the number of compounding periods in a year is infinite, as many as you want. Okay? So you might think, wow, that's a great deal, right? I'm always getting this interest added on, so I'm going to be making tons of money. Like, it's going to just explode. It's really not the case, though. It doesn't happen that way. The number of compounds, if we were to investigate that a little bit more, increasing the number of compound periods doesn't really make a huge difference.
If you do rule of 72 for 2%, it's 36.
Yeah. Right. So what ends up happening is the bigger indicator, or the more important part of the equation that will help you to make more money is what do you think? What's the crucial number? Your interest rate. The rate makes all the difference in the world because that's affecting your base, right? That's what you're adding onto your base. And if that number can increase enough, that's going to be, And that's why banks always publish, check out our rates, look at our rates. We have great rates. Rates. They keep talking about rates. That's why, is because that's really where you can make your money, is if you have a good interest rate. But in any event, so this one, though, it's kind of the same thing. As far as what, A is the amount, P is the principal, T is the time in years. And notice how on this one, and R is the rate, sorry, missed that too. This one, there is no K anymore, right? Because the number of compounding periods is pretty much, gone. So, example with this one, in the interest of time here, but it would work the same way, though. You plug things in, figure out whether you want time or amount or whatever, but in the interest, I didn't even mean to do that. Okay, so these other two equations, these are ones that are going to be a little bit more useful as far as, if you really want to make an investment, or if you are taking a loan, that sort of thing. There's one called future value, and there's one that's called, we're going to start with future value. And future value refers to these things called annuities. Does anybody know, Dave Ramsey people, what an annuity is? Yeah. What do you say? Savings account through an insurance company. Okay, and how do they work?
Don't you get paid interest rates based on how well the insurance company does?
Nope. I think there might be annuities that are through insurance companies that work that way, where the rate changes based on things. In general, though, so that's one type of an annuity. But in general, though, any kind of annuity is basically of the formula, you don't just put a sum of money down and let interest calculate on it. You're continuously putting more money into it. Okay? And so there are some that work that way, but in those, still, you have to keep putting money into it to make it work. So, and with those, you're investing in that company. You're giving them your money to invest. But basically, any kind of annuity is, like, let's say every month I'm going to take $200 out of my paycheck, I'm going to put it into this account. And I'm going to keep putting the money in, and I'm not going to stop until I'm ready to be done. Okay? So that's the assumption that gets made with these, is that you're kind of putting some of money into an account. So, an amount of money is repeatedly invested every so often. Maybe you want to do it every year. Maybe you want to do it every month. With me, I have an annuity. I do it every paycheck, and I get paid every 2 weeks. Okay? So we'll do a little example. We'll do some calculations for me. You'll see what my retirement little nest egg is going to look like. Okay, so the equation for future value, though, is this. FV equals R. And again, these are equations you will not have to memorize, thank goodness. 1 plus I to the n minus 1 over I. And I is equal to R divided by K. Okay, so what is all this stuff? Well, FV is the future value. So that, I mean, it's kind of self-explanatory. So I'm investing all this money in my annuity, and I want to know how much money I'm going to have when I'm all done. That's FV. That's the future value of it. You know, how much it's going to be worth in the future. So, just going to call it future value. R is this repeated amount of money that I'm putting in all the time. Okay? So, in your book, they call it a periodic payment. It's how I choose to put in every so often. Okay, so the N, the how many periodic payments I make. Okay, R is going to be the interest rate again. Oops, rate. And K, number of compounds per year again. So be careful. One easy trap to fall into with this one is instead of using N as how many periodic payments, people use N as just how many years or whatever. You actually have to count the number of payments. Yeah?
So is I not square root of -1?
No. Yeah. Not that I. Yeah. Good question. So we've been talking about that in Chapter 2. There are no imaginary numbers in this, okay? It's just I is for interest, and yeah, you got to know the context with which you're working, and this is not imaginary numbers time. No, not at all. Yeah. -3, square root of -$3 or something. No, definitely not imaginary. Okay. Well, in some respects, it's. So let's say Mr. Herrick pays. I do $200 every 2 weeks. Oh man, I don't even know what the percent is, so I'm gonna have to make up a number here, so this won't be terribly accurate. So let's say, the interest rates on these are typically a little bit higher, so let's say 3%, but I'm not sure. I'm gonna say 3%, but that could be wrong. So at 3%, so how much will I have after, and I'd like to teach for like 35 years, so let's say 35 years. I've been doing it since I started. So if I put in $200 every 2 weeks for 35 years at 3%, how much can I expect to be done with? What? I do. It's called a 403B, but it's an annuity. It's like a 401k. 401ks are for businesses people that make a profit, those sorts of things. 403B is for people that work for nonprofits, like schools and stuff. We don't make money off you guys necessarily. I guess that's political and debatable, but we're not going to talk about it. Anyway, so let's work through Mr. Herrick's little retirement nest egg here. I'll tell you, my periodic payment is my $200. 1 plus. Now, whoops, there's no 1 there. 1 plus. Now, my rate over the number of compounds per year. My rate was 3%, so 0.03 divided. How many compounds do I have in a year? If I'm investing every 2 weeks, or every 2 weeks. 26. Yeah, so this should be 26. All right. And then to the n, but n is how many periodic payments? How many total periodic payments? It's not just 26. It's 26 times 35. What is it? 910. Okay. Said big exponents, usually with these. Minus 1, and then divide that by the same I, 0.03 over 26. All right, so let's simplify the thing up a little bit here. So 200, 1 plus 0.03 divided by 26. And I'm going to make sure I get lots of decimal places here again. So 1.001154. Let's say I'll keep 6 again. Raised to the 910 minus 1. And then this is all divided by 0.03 over 26, which is just the 0.001154. Okay, so we'll keep working our way through this. So 200, I'll raise this to the 910 and see what that gets us. Okay, so I've got 2.85592 minus 1 over 0.001154. All right, so that minus 1 divided by 0.001154 times 200. All right, so my future value of my annuity, $321,650.24. So as long as I hold that 3%, diligently putting my $200 every paycheck into this thing, over the course of my entire career, I can make $300 grand with that money. Yeah.
Is it like a set that you have to put $200 in, or can you put like any amount?
You can put any amount. And in fact, realistically, honestly, mine's changed. I was putting $250 in for a while, then I backed it down to $200, and so it kind of fluctuates a little bit. And then the calculations get really confusing. But so for you guys, we're just going to assume same amount all the time, same percent the whole time, because those change too sometimes depending on the type that you have. Yeah? Mine's fixed. Oh, goodness gracious. Don't get an adjustable. Those are awful. Yeah? Question? I just typed this into my calculator just like this.
Is it 200 times whatever?
Yep, 200 multiplied by that whole thing. Just be careful. Like what I did was I did the calculation in the parentheses first. So I did this minus 1 divided by that, got a number, took that times 200, and that's what I got. Yeah. Now, here's my question for you, though. Have I actually made $321,000? Not technically, right? Because I had to put money into this thing, right, for 35 years. So how much money did I actually make from this? You know, I could have taken this $200 and put it in my mattress every 2 weeks instead. How much money would I have then? Yeah. Right. Yeah. So it's still a decent chunk of change. So doing an annuity versus not is kind of a no-brainer, right? If you can afford to do it, because if I $200 had 910, right? So basically, I do 200 times 910. That's how much money I have to put into this thing, which I think people have already calculated for us, but let me verify here. So I $182,000 of my own money. Not spread out over 35 years, 200 bucks at a time, but I end up making a lot more than that then. Okay? So like I said, if you can afford to do it, because, that's over $100,000 profit there. Now, so that's the good side of interest, annuities. When you have the money available to put into it and can use interest to your favor, usually, though, people find themselves on the other end of that stick, though. And where do we usually find ourselves when we're owing interest to somebody else? Loans. You want to buy a car, you want to buy a house, all those big expensive things that you don't have the money to pay for right away. So you have to borrow somebody else's money, and they're sitting on the other end of this equation, and you're on the other end, like, shelling out all the money extra. Yeah? When do I get paid? When I retire, I can tell the bank I want to cash this in, and they hand me a check. Now, usually that gets spread out over a certain amount of time, though. They'll say, okay, so every month we're going to give you a check for 15 grand or something, or whatever it is. Probably not that much, but yeah. Or you could say, yeah, I want it. I mean, it's your money. I guess technically you could say, I want it all in cash. Give it to me now. I'm cashing it out, Yeah. Look, everybody, I just cashed out my annuity. Don't chase me down the street. I thought there was a hand. Was there a question? No? Okay. So, is the other. So, is like for loans. Okay. As a mathematician, there is nothing that pisses me off worse in the world than interest on loans. I looked at my mortgage one time and figured out exactly how much I had paid off and how much I still owed and how much money had evaporated into interest, and oh my God, so much money. So, yeah, if you can pay for a house in cash, do it, but good luck being able to do that. Shoot. It's a pretty similar looking formula. It's got some of the same variables. They all mean the same things, but it's set up a little differently. Okay? So PV, value. Okay? Value is another way of saying how much you still owe on a loan. For. We usually have a monthly payment associated with that, right? The bank calculates for us this nice number of every month you have to write a check for this much. And that's a periodic payment, right? Just like the annuity. Except the annuity, you got to choose. With a loan, the bank tells you. So this is your periodic payment amount again. And then the is equal to the, what did we say that was, yeah. And the R is the rate, and the K is the compounding periods in a year. And then the N is the number of payments you're going to make. Okay, or number of compounding periods total. So how many total payments you're going to take. And that should be it. Yeah. So, what? Student loans? Student loans actually aren't terrible compared to some other ones. Student loans, I think their interest rates on those, sometimes are like 1%. They're really not that bad. The ones where they really get you are the credit card ones. If you don't pay off a credit card bill and then they start socking you with this, it's like 22%. Yeah. I'm not joking. See, if you don't pay off a credit card on a certain month, they screw you. Now, a home loan, you're looking at probably somewhere in the neighborhood. Right now, it's not bad. It's like 3-4%. It used to be like 6-7%. Well, it's true. That's true. Car loans are usually right around the same. I'd say probably 3%, 4%, somewhere in there right now. Let's do a house. Let's just take a look at a house. Let's say Yeah, I really want to do this example, though, but I am kind of running out of time. Let's say you want to buy a house that's $200,000. You find a loan for 4%. And it's going to compound. And usually when you buy a home, you have a choice of, typically it's a 30-year loan or a 20-year loan or a 15-year loan. You always go with the 15. Yeah, I just refinanced into a 15. But let's say you're just out of college and you're a little, not sure of things, and you're like, I can afford this if I do it a 30 years. So let's say, so you're going to use a 30-year loan. Your kids will be out of college by the time you pay it off. So how much will you spend? All right, so we're going to do as much of this as we can. So this equation then, now this one's going to work backwards, right? Because we're trying to figure out how to spend. We know the present value is the $200,000. We're really searching for R. Because if we know R, we know how much we're going to have to spend every month. And then we multiply that by 12 months in a year times 30 years. Spending on it. So we're going to leave that one alone. Then we're going to do 1 minus 1 plus R over K. The rate was 4%. Period compounds per year would be 12. And that's to the negative 30 times 12. 360. And then all over this I again, 0.04 over 12. Okay, so we have 1 minute left in class. So what I want you to do is, for your homework, I want you to finish this. Tell me how much you're going to spend on the house, okay? You've got this, and then you've got like a handful out of the textbook too that I'm going to show you here. Sorry.